Okay, so today we have two quadratic equations, and this time instead of factoring them, we want to use the square root property. Remember, we've already talked about not every expression in algebra factors. So factoring is not always going to work to solve a quadratic equation. So if you look at my first equation, 36x squared equals 4. What we want to do here is solve this doing the square root property. So step one is isolate the term that is squared. The base that belongs to that exponent 2 has to be by itself on the left side. So if we look, here's our exponent 2. So the question is, who owns it? Does that 2 belong to 36x, or does that 2 just belong to x? Correct. There's no parentheses here, so the base is just x, which means we have to move the 36. And to move a 36 that's connected by multiplication, we perform division. 36 divided by 36 cancels out. That leaves us x squared. 4 over 36 is a fraction, but it's not in lowest terms. The greatest common factor here is 4. So 4 divided by 4 is 1. 36 divided by 4 is 9. Do not feel the need to go get a calculator. If you type 4 divided by 36 in a calculator, it's going to spit you out a decimal that repeats. And in higher math, we do not like decimals that repeat. We don't like to write them with a little bar. So we'd rather have all our solutions in fraction form, in rational form. Okay, so that was step one. We isolated the term that's squared. Now this should make sense. The opposite operation to squaring is doing a square root. And because this is an equation, we have to keep balance. What you do to the left, you do to the right. Squares and square roots are inverse operations, so they cancel out. Just like here, multiply and divide canceled out. So that's just going to leave us with good old x. Now the problem is because this was a quadratic equation, we're guaranteed to have two solutions. So here's the stink. You have x equals, but we have to have two answers here. So the way we're going to put our two answers is we're always going to put a plus or minus symbol to show one answer is going to be positive, one answer is going to be negative. Now, can we leave the expression square root of 1/9? Absolutely not. 1 and 9 are perfect square numbers, which we should be square rooting them. So we know the square root of 1 is 1. We know the square root of 9 is 3. So the square root of 1/9 is 1/3. There are two solutions here. Some professors or some textbooks prefer using the plus or minus symbol. Some others prefer to write the answers as two separate solutions. Okay? Either one's acceptable. Now you're probably saying, Miss Black, why, when we do a square root here, do we put a plus or minus? Because in our previous modules, when we did a square root, we never did that. That's a good question. Let me take a moment to explain that. In mathematics, in our previous modules, back to modules, 13 and 14 and 15, when we were talking about square roots, if I write the square root of 1/9, and I ask you what the value of that is, you told me 1/3. You only gave me a positive answer. And this is the reason why. When the square root symbol is in the original expression, then it's understood in math only to give a positive answer. So in those previous modules, all the square root symbols were already there. So it's understood you just give the positive answer. However, if you look here at the original equation, there was no square root symbol. You put this symbol in. And when you put this symbol in, there's technically two answers. Because if I asked you in words, what number times itself would make 1/9? You could say positive 1/3 times positive 1/3 would be a 9th. Negative 1/3 times negative 1/3 would be a 9th. So the moral of the story is, if the square root symbol's already there in the expression, yes, you only give a positive answer. But if you physically draw that square root symbol in, then you must put the plus or minus to understand there are always two solutions. Okay, let's try the other equation quickly. So we know it's quadratic, and we know we want to do it by the square root method. So the rule says you have to isolate the term that's squared. So here's the square. It just belongs to the x. So we have to move all the other numbers over. So we'll add 24 So we have 2x squared equals 24. We still have to move the 2. We'll move it by division. That's x squared equals 12. So again, this exponent only belonged to base x. So that's why we isolate it. Now to get rid of a square, we do the inverse operation. We square root. Squares and square roots cancel out, just like add and subtract cancel out, just like multiply and divide cancel out. We get x equals, you're going to put a plus or minus, and then we're going to talk. Can you leave a square root of 12? Absolutely not. Now I know 12 is not a perfect square, but it has a perfect square number in it. 12 can be factored to be 4 times 3. And we all know the square root of 4 is 2. A 2 comes out. We all know we can't square root 3. It stays inside. And there are our 2 solutions. Very simply done. I'll give you a hint. You'll know you're going to do the square root method when you have the term that's squared and a constant. When you have a term that's squared and a constant, it is very quick and easy to solve a quadratic equation using the square root method. Thank you.